India is an agricultural country. According to estimates, agriculture employs more than 50% of India's workforce, and it is the primary source of livelihood for majority of population in India. With the rise in crop produce, farmers have another menace to deal with, which accompanies the production of crops, and it is none other than the crop residue or the agro-waste. The paddy crop is usually harvested between the first and last weeks of October. When paddy is harvested, with only 10 to 15 days left between the rice harvesting season and the wheat sowing time, farmers find burning the stubble to be the most easy, quick, and economical way to eliminate the paddy straw. Crop residue burning gives rise to huge clouds of smoke, which has adverse impact on environment in northern India. Open crop residue burning continues on a massive scale. The only way to prevent this crisis was to incentivize agro-waste and generate a market force to consume its huge quantity. The agro-waste is collected, stored, dried, and afterwards processed into biopellets in separate units, which is then used for power generation in coal-fired power plant. And India's biggest power producer, NTPC Limited, realized the power potential of these biomass pellets and has since created a huge market force. NTPC has issued a tender to procure 20 million metric tons biomass pellets over a period of 4 years. That is, 5 million metric tons on annual basis. The quantum of biomass which the NTPC envisages to use per annum has a potential to generate 1000 megawatt per year. Biomass pellets are characterized into torrefied and non-torrefied pellets. NTPC Dadri uses non-torrefied biomass pellets for co-firing, but before co-firing of biomass pellets in boiler, following processes are adopted at plant. This starts with truckloads of biopellets arriving at the NTPC biomass unloading yard. The details of truck, the biopellets seller are noted down. The next step is the collection of samples from the truck top. The official personnel land on truck top after climbing a ladder placed safely near the truck top. The personnel remove the top 25 cm layer of biopellets and then collect samples from 4 to 5 random spots. These samples are tagged and then taken to the chemistry lab. In the lab, the samples are thoroughly mixed. They are further reduced by coning and quartering method till the samples are worth 4 kg in weight. The sample is then divided into 4 equal parts of 1 kg each. 1 part is for seller, 1 for referee, 1 for NTPC, and 1 for fines. All of the samples are packaged and tagged. The personnel then take sample worth 100 grams and crush it for a definite period of time in a mortar pestle. The crushed sample is also put through 1 mm and 3 mm sieve respectively. The quantity put through the sieves is also reported in percentage. Parallelly, the sample is also tested for total moisture. This whole process in the chemical lab lasts for at least 1 to 2 hours. If the sample meets the NTPC's technical specifications, then the sample of biopellets is cleared for unloading. If it does not, then the sample of biopellet is rejected. The sample is also tested for gross calorific value (GCV) and fines in a separate test. After getting the go-ahead from the chemistry lab, the truckload of biopellets gets weighed and unloading of biopellets begins soon after. Unloading is done very carefully, maintaining all the safety standards. After unloading, a bulldozer pushes the biopellets into reclaim hoppers. The NTPC personnel rotate the operating wheel and push the pellets from the hoppers through the mechanical vibro feeder onto a conveyor belt in a fixed quantity. The conveyor belt carries the pellets ahead. Then coal gets added to the conveyor belt from a separate hopper. The conveyor belt containing the coal and the pellets reaches the bunker from where it is fed into the mill. The mill is where both the pellets and coal are thoroughly pulverized mixed. This pulverized mixture goes into the furnace, which is used to generate electricity. This entire process is called biomass cofiring. It has been hailed by the United Nations Framework Convention on Climate Change, UNFCCC, as a technology which helps mitigate greenhouse gas emissions. UNFCCC recognizes biomass cofiring as a carbon-neutral technology for mitigation of carbon emission from coal-based power plants. Biomass cofiring makes a better alternative. If the paddy stubble isn't processed into pellets and directly torched, then it produces toxic cloud of smoke which adversely impacts the health of people. It causes irritation in eyes, nose and throat. There have also been reports of cough and wheezing. Another impact on people in northern India is spending crores of rupees every year on treatment for ailments caused by stubble burning. Studies have shown that crop residue burning releases huge amount of greenhouse gases. These directly lead to environmental pollution and are also responsible for smog caused due to low temperature, the haze in northern India. Crop residue burning has other harmful effects too. The heat from burning paddy straw penetrates into the soil, elevating the temperature. This kills the bacterial and fungal populations critical for a fertile soil. On the other hand, biomass cofiring leads to significant reduction in greenhouse gas emission, being carbon-neutral technology. It also improves flame stability due to high volatile content of biomass. One doesn't have to worry about slagging, corrosion, fouling, and ash utilization, which happens in boilers in case of combustion of coal. Along with reducing pollution, biomass cofiring gives a huge boost to the biomass sector by generating many folds employment than other sector. It also generates additional income for farmers who now get paid for their agro-waste. NTPC's technology of biomass pellets opens up new avenues. Generated from agro-waste, biomass pellets have the ability to fit into existing energy systems without the requirement of additional machinery or infrastructure. They are the future and will be an essential force in driving the energy economy of tomorrow.